Welcome to the Burnt Brass Homestead channel. In this video, I show you how I built a chicken incubator using a styrofoam container and thermostat module to hatch chicks on the homestead. An incubator comes in handy to control the hatch date of baby chicks. Maybe you want to hatch new chicks towards the end of winter or early spring. An incubator also allows you to hatch chicks during times there are no broody hens to sit on the eggs. I made this incubator 2 years ago and had successfully hatched chicks in it. I chose styrofoam because of insulation, but you can use wood, plastic, or even sturdy cardboard. The top here is plexiglass, and what I did was I drew a line for the shape of the plexiglass, and then I came in about 1/4 of an inch on each side, and then I drew another line. So I cut all the way through on the line, the inner line that I drew, I cut all the way through. But the outer line, I only cut in a little bit to allow this plexiglass to sit on. And this is material that I already had stored from a project that I did years ago, so I didn't even purchase this at the time. So I drew 2 lines, one the full size of the plexiglass, and then I came in about 1/4 of an inch on each side. I cut through all the way through on the inner lines that came in 1/4 of an inch, cut all the way through, and then I cut a little lip out here so that the plexiglass can sit at the level of the lid here. This is the original look of the incubator when I built it 2 years ago. I cut a hole in the side for the fan to pull in fresh air. I have since closed that hole in the updated design, so stay tuned for that video where I make a lot of updates to make this incubator fully automated. The thermostat controls the light bulb, which is used to heat the incubator. The ideal temperature for a chicken incubator is 99 to 102 degrees Fahrenheit. However, to compensate for the cold room the incubator sits in, I configured the thermostat for 99.5 through 103 degrees Fahrenheit, which is 37.5 to 39.5 degrees Celsius. When the temperature drops below 37.5 degrees Celsius, the thermostat is configured to activate and close the circuit, thereby turning on the light bulb. When the temperature reached the threshold of 39.5 degrees Celsius, it would open the circuit, thereby shutting off the light bulb. This thermometer only operates in Celsius. I will leave a link to it and all parts I purchased to build this incubator in the event anyone wants to try building something similar. This ladder structure was to rotate the eggs easily by moving the structure left or right, in which case the eggs would turn. The eggs would be rotated at least 3 times a day. I chose to do this early morning, early evening, and just before bed. That is when I remembered. Now let's take a look at the thermostat, fan, and light bulb wiring. On the thermostat module, there are 4 connectors. The first, starting from the left, is K0, K1, 12 volt, and G and D, which is ground. Both the K1 and 12 volt are positive. I used an old power cord from a fan or other device that no longer worked to power the light bulb. So I spliced the power cord and connected one end of it to the K1 connector on the thermostat module. The other end of the spliced power cord was connected to the black or positive wire of the light bulb. And the white wire from the light bulb went into K0. To power the thermostat module itself, I spliced a power cord of an old AC/DC adapter. The red or positive cable of the AC/DC adapter is connected to the 12 volt on the thermostat, and the black wire goes into the ground. In regards to the fan, there is one black and one red wire that goes from this thermostat module into a hole that connects to the fan inside the incubator. The red or positive wire goes into the 12 volt and the black goes into the ground of the module. So now I'm going to set the thermostat to work for the incubator. It's very simple. This far left button is the set button. You hold this down to cycle through the P options, P0 through P6. We're not going to use all of those options. We're only going to use two of those options, P0 and P1. And the last setting we're going to do is the temperature. That's it. It's very simple for this, how we're using this thermostat for the incubator. So the first thing to do is click that set button quick and then cycle through to the desired temperature, which in this case is 37.5. So that's 37.5. If you go too high, just use the far left button to cycle back down. So now that's set to 37.5. So if I click that once, you see it's set to 37.5. Now the second option that we're going to set is heat or cool. And basically the difference between the heat and cool is the cool, if you set it to C, it energizes the component, and if you set to heat, it de-energizes it. So we're going to go with heat. So if you hold this down, the set button, until it gets to P0, and then from there hit it to set it again, and then you can hit C, select C or H, and we want H. So again, the reason why we want H is because when we set the thermostat and it reaches the highest temperature, it will shut off. That red light will go off. So now we want to do is set the threshold, which brings us to the second option that we're going to set. So hold the set button, and when it reaches P0, cycle through to P1 and then hit set again. And by default, it's 2. Basically what that means is we have the temperature set to 37.5, and if it goes up 2 degrees to 39.5, it will shut off the heat, the light bulb. It's time to test the functionality of the thermostat. The threshold temperature is set at 39.5 degrees Celsius, which is roughly 103 degrees Fahrenheit. So the thermostat should turn off when the temperature reaches 39.5 degrees Celsius. The room that this incubator sits in is a bit cool, so I compensate for that by making the threshold a tad bit higher than the IDEA threshold. You may not need to do this. Now I lift the lid to speed the cooling of the incubator to validate that the light bulb turns on when the temperature drops to 37.5 degrees Celsius, which is 99.5 degrees Fahrenheit. Perfect. Now we can move on to the next stage. Now, for those of you who want to keep it simple and just have the thermometer monitoring the temperature in the incubator and having the thermostat turn off and on based on the settings, then you can pretty much just stop here with the wiring, and you can just manually create something where, and you don't even have to create something like this. This just made it easier to roll back and forth. but you can actually just set the eggs in here. I would put some either rice down, or I use pine shavings, and you can just lay the eggs right in here and just turn the eggs individually. But I had something like this to make it easier, right? Also, if you want to make something like this but you don't want to open this, what you can do, and that's what I was going to do if I didn't pursue the automatic egg turner, I was going to put a hole here and a hole in the base on this side. I was going to tie a string to either side, and then I was going to have a nut here, a nut, and then I was going to glue the nut in here, the outer, the outside of the nut, leaving the inside clear for the string to go through. And I was just going to pull that string back and forth. So I was going to pull it this way and pull it that way, which would have dragged this to roll this without opening the incubator. So that's another way you can do it manually without opening this. That's just something I came up with. I don't know if it would have worked. I think it would have worked because the hole would have been thin enough, whereas though a lot of humidity did not escape. And like I said, you would have just put the bolt here, glued the outside of the bolt to, the nut here, glued the outside of the nut to this. And the reason why I was going to use a nut, because pulling that string back and forth, I didn't want it to wear on the styrofoam. So pretty much that's where you can end it as far as the automation with the incubator. Building this incubator was extremely cost effective. While it is obvious that I can scale down by simply limiting the number of eggs I put in the incubator, it may not be as obvious that I can scale up using the same incubator by adding a second level and having the motor rotate both levels. Or I can go big and build a bigger housing unit and egg turning structure using the scrap wood we already have here on the homestead. The only upgrade would be adding another light bulb or two, which I also have here on the homestead. So this thing can be scaled up at no extra cost. The only cost will be my time, which I enjoyed working on this project. I hope the instructions on how I built this incubator was clear for anyone who wants to give it a try, but please do your own research on wiring, as I am not an electrician by any means. Please like, share, and subscribe to help this small channel to grow.